52, longest word. Let's see what it's asking. All right, so in this one, we're given some text. I guess it's going to be like a sentence or something like that. And the idea is that we want to find, out of all the words in that text, which one is the longest. And so when we say a word specifically, they're giving us a nice definition here. They're saying a word is a sequence of consecutive English letters. Okay, so that's kind of important. I mean, we want to define that because otherwise we might think like, well, how are we defining a word? Is it just something separated by spaces, in which case we would like, include the comma over here. But we don't want to. It's just the letters themselves. So just the ready, the steady, or the go. And then, once we have a clear idea of what the words are, we want to find, well, which of these is the longest? And in this case, yeah, it's steady. Now, if we look at the second example over here, notice we got some other weird characters in here. So they want to make sure that we are actually just checking for the letters here, not just any character, not like just anything but white space. Like it's got to be letters specifically. Okay, and another thing is in terms of what we're actually returning, it's not just the length of the longest word, it's the word itself. Okay, so like in this case, it's steady as opposed to being like the number 6 representing the length of the longest word. Okay, and then another thing to pay attention to, the constraints, not too bad. I mean, it's just 50 characters long. And I do have to say, I think a lot of these tasks would be like a little spicier if we did actually give them some pretty outrageous constraints. But then again, there are only 6 tests here, so there's not that much we're going to be covering. I guess that's another suggestion if we wanted to improve these. But the point is, okay, for this particular one, basically our game plan is going to look like this. So we want to do a function to check if character is a letter. Okay, that's sort of the first thing we're going to want to do. We want to know if this thing is a letter, if it's going to be part of a word. That's probably going to be a useful thing for us. So we'll make a function for that. Then after that, we're going to use that function to just find all the words in the text. And then once we've found all those words, we want to find the longest word from there. Okay, so that's basically our game plan for this one. Just make a bit of space between these. So right off the bat, let's start by doing this function to check if a character is a letter. So let's give it a good name. Let's call it something like isLetter, something nice and self-explanatory. And it'll take an input that's going to be a character. What are we going to return from this? Basically, we're just going to return if this thing is in fact a letter. So to be a letter would mean that you're between A and Z. Or it could mean that you're a capital letter, which in that case would mean that you're between capital A and capital Z. And notice that's within the inclusive range. So it could be lowercase a, it could be lowercase z, it could be uppercase a, it could be uppercase z. Okay, so that's basically it. If we want to check if something's a letter, that's our function. That's what it's going to do. Let's test it. Let's see if it's actually working. So we'll say return is letter, and we'll give it an input of P. Yeah, we'll see if that works. That's true. What if it was a capital W, let's say? Also true. Okay, good stuff. What if it was this? Or, yeah, just that. Let's try that. Yeah, false. That one's not working, so good. It's not a letter. What about a space? Let's just be sure about that. Okay, also false. Now, you might be looking at this and thinking like, well, why wouldn't we just say like the character has to be between uppercase A and lowercase z? Couldn't we do something like that? And yeah, we could, but the problem with that is if we actually take a look at our ASCII table here, we notice that 65 is our code for uppercase A, lowercase z, it's 122. So yeah, it would make sense to go from uppercase A to lowercase z, like as opposed to the reverse. But the thing is, there's all this extra junk in the middle, like including these square brackets. And I think that's part of the reason test 2 has a bunch of these, because if instead of this, if we were just saying, something like this, return uppercase A less than or equal to character, and character is less than or equal to lowercase z, then something like this would still be false, but something like this now would be true. And so that's why this isn't really enough. Even though it does, look a little nicer, it's not really getting the job done. It wouldn't pass that second test properly. So there we go, false. That's what we want. Okay, so hopefully we're all convinced at this point that our function's working. Our isLetter function is doing what it's supposed to be doing. So from here, we can do some other stuff. So we want to find all the words in the text. So here's what we'll do. Let's say let words be assigned the value of just this empty array. That's where we're going to store each of our words. And we sort of want to construct each word like one at a time. So we'll say let word be assigned the value of this empty string to begin with. And then as we move on, as we go through the text, we'll find, we'll build up the word to the point where it's no longer a letter character, and then we'll just push it into our words array. So let's do that. We're going to go through the text. We're going to say for let I be assigned the value 0, I is less than text.length, I++. And then within here, basically what we're going to do is we'll say let character be text at I. And what do we want to check? Well, we want to say, is it a letter? If is letter character, then what do we want to do? Well, basically just add it on to the end of the word. So word gets character concatenated to the end of it. So keep in mind this plus equals is a little bit different than like a mathematical plus equals. Normally that would mean like add whatever number this is to the current value. The thing is, this isn't a number, so this is not addition, this is concatenation. So it's putting basically this character, it's putting it onto the end of the word, which starts just as a empty word. Okay, so if we were to do something like this, well, right now, basically, this is just gonna take all the characters, right? all the letters, and put them together in this one word, and it's gonna skip all the ones that aren't letters. But what I actually wanted to do is, when it gets to something that's not a letter, I wanted to first of all say, okay, well, we've reached the end of the word then. In fact, maybe I'll make a comment about that. That means we've reached the end of the word. Okay, so what do we want to do at the end of the word? Well, we want to say words.push word. Okay, so basically words is our array. It's keeping track of all the words that we have. And we want to put inside it the word that we've been building up. And then after that, we want to say, okay, that word you've been working on, we're going to reset it because we've just stored it. We've got that one. This one's going to be blank. And let's see. Okay, for now, let's run this. We'll just say return words. I'm just curious about what it's actually going to be giving us here. Okay, so we're getting the words that we're looking for. The problem is we're getting these kind of like spaces in between, and that's because basically it's saying, okay, letter, yeah, letter, yeah, letter. So it's building up the word, and then it gets to the comma and says, oh, that's not a letter. So, okay, we're going to push that into our words array now, and we'll move on to the next one. But then it has this space, and it says, oh, okay, that's not a letter, so we're going to push that into word and move on from there. So that's not really exactly what we're looking for, because we don't want to have this just empty string in here. Although I do have to say it's not going to make much of a difference, because it's not like that's ever going to be longer than the longest word in here. So maybe we don't have to care about that, but I sort of want to be proper about this. So there are two ways we could deal with this. We could say something like if word.length, so like if there actually is a word there, then yeah, put it in the array. So we could do something like that, and then yeah, we're just getting the words that we're looking for. That one's good too. That one's not good. Okay, so we're gonna look at this one now, I guess. I mean, basically the idea here is when we get to the end of this thing, well, okay, I'll put it this way. We're never actually getting to this because everything we encounter here is a letter. So that means at the end of this, we probably want to do this same sort of thing. In fact, pretty much that exact thing. So if there is a word queued up at the end there, then yeah, put it in the array. Okay, so these are all looking good now. They're giving us what we want. I do want to say though, I think we can probably handle this a little better, because the thing that's bugging me about it is, specifically in the second test, it's kind of doing this a bunch of times. It's kind of going to this one and saying like, okay, we reached the end of the word, so all right, we'll push it into the array, we'll restart the word. And then again, it's saying, oh, okay, well, the word is still nothing, so okay, we won't push it. And then again, it's going to here. And then again for the comma. And then again for the space. Like it just keeps going into this one. And I kind of figured like, once we know we're at the end of the word, we might as well bring it right to the start of the next word. So what do I mean by that? Well, basically I'm going to use a little while loop in here. I'm going to say while not is letter, and we'll say text at I plus 1. So not the current character, but the next one. So while the next character is not a letter, just increase I. Just keep it going. Like move it on until you find the next letter. Or at least until the next one would be a letter. And the reason I say that is because there's going to be this I++ that's naturally going to happen there. So in case you're wondering why I didn't just use text at I, why instead I'm using I++, I+1, it's because we're looking at the next one. We know there's going to be an I++, so otherwise we'd miss the first character of the other next word. Now the other thing we need to check here is that there actually is a text at I+1, so I'll also say, well, I is less than text.length plus 1. I mean minus 1. Yeah. Yeah, because otherwise, like, if it's equal to text.length minus 1, well, that would mean it's already at the end, and so if we try to look at the next character after that, there isn't going to be one. Okay, so I think that's going to be just as good as doing the if word.length that we were doing before. Okay, so that's looking good, that's looking good, that's looking good. Okay, awesome. So we've got the things we're looking for. Now we just need to know, well, what's the longest one? Find the maximum length word. Okay, so let's do that. So great, that's giving us all of our words, which is awesome. And then for this one, we want to find the maximum length one. So this is a little tough because I don't think we'd be able to just do like a math.max on this. We've done this sort of thing before. We've done a math.max on, like ... words. The ... is a spread operator, so that's why, well, that's basically so that we look at the words inside the array as opposed to using the array itself as a single argument for math.max. Okay, let's run this, and let's see if that's actually working. Well, no, it's not. It's not really making sense for us to look at the math.max of these words. We're not really easily able to compare them. So really what we're talking about when we're talking about math.max is which one of these has the biggest length. Not which one of them is the biggest. It's not like they're numbers and we're easily comparing them. Is that we want to know what's the biggest length, what is the longest one here. So the way we're going to do this, basically we'll just say let longest word be assigned the value of well, I guess we might as well just start it at words at 0, because we'll correct this otherwise. So we'll say the longest word is just going to be that, or you know what? Here, just to make the loop a little easier, let's just make it an empty word. And eventually we do want to be returning the longest word. It's the thing we're looking for. But we're going to do this first for let word of words. Yeah, for let word of words. We're going to do a loop that basically goes through that, and it's going to say longest word is going to be, well, okay, let's back up a second. If word.length is greater than longest word.length, then we'll say longest word is assigned the value of word. And let's see if that works, if that's going to give us the longest one. Ooh, and it seems to be. Okay, it's passing all 3 of these tests, so it's giving us the steady there, same as that one, and our ABCD over there. And I think that one was just to make sure we were looking at both uppercase and lowercase characters in our isLetter function here. So let's submit that. We'll see if it's passing all the hidden tests as well. This is a real moment of suspense. Okay, and there we go. Awesome. Okay, so we've made our first dent into the land of logic over here. Nice job. But is there a way we could do this maybe more efficiently? If we take a look at this, there's a lot going on here. In particular, let's see. So basically, we've got this function to check if it's a letter. We're going to keep that the same for now. Maybe we'll look at some other ways we could do that in just a sec. But I mainly want to clean up this part down here for now. So basically, there are two phases. We've got the phase where we're finding all the words, and then we have the phase where we're figuring out which one of those was the longest. And I believe that we can do better than that. I believe that we can sort of merge those two components and sort of do both of them at once. So I want to try to do that now. So we'll take this stuff, we'll just we'll copy it from down there, and yeah, we'll try to modify this now. So instead of even looking at this words array, let's just start with this. So let's take this longest word thing and we'll put it over here. And I'll say find all words in the text and record the longest one, I guess. We're going to do both of these things in once, so or at once. Yeah. Anyway, point is, so we're going through the text string here. We're running through the whole thing, and basically the idea is that we're creating words, and then we get to this point where we're saying words dot push word. Well, instead of that, what I want to do is basically this. Okay, so we'll take this thing and we'll replace this with that. Yeah. Yeah. And then I guess we might as well do the same thing over here. So this one's maybe a little more complicated. So if word.length and then if word.length is greater than, well, I don't know. I don't even really know if we need this part here, but there we go. And then find the longest word. Well, we've already done that. Okay, sorry about that. Let's try running the tests on this now, and something's going wrong. So words is not defined. Yeah, that's true. It's not. Where are we talking about that? So 24. Whoa, what's this all about? Where'd that come from? So yeah, where did that come from? That's weird. Anyway, I guess I just didn't paste that in properly. Let's try running that now. And there we have it. Okay, so we're still getting all of our longest words in this case. We've cleaned it up, or I shouldn't say all of our longest. We're getting our longest word. We've cleaned it up so that we're no longer like looking for all the words, keeping an array. So not only is this going to be better in terms of our time complexity, because we're only going through the text once, and then we don't have to go through the words array after that. Not just that, but it's better for our space complexity. It's better for memory because we're not actually storing an array of words. We don't need to worry about that. We just have the longest word in here and then the other word that we're building up. So at most, we're just going to have two words on the go here, which is nice. Okay, great. So can we submit that? Can we see if that passes all the hidden tests? And it does. Okay. So that's nice. That one's working for us. It's getting the job done, which is good. But maybe we can get the job done better. So let's give this another try. I'll put this one over here. And now the first change I want to make is over here, when we're checking is letter, I want to do this a little smarter. So instead of doing all these double inequalities and stuff like that, I want to use a regular expression. I mean, this is a natural thing. It's probably something we're getting used to at this point, that we are going to use a regular expression if we're talking about a string and analyzing some sort of property or pattern about the string. So our regular expression is going to be something like this. So it'll either be A to Z or lowercase a to lowercase z. And we're going to do a dot test on that with character. Let's see if that still runs, first of all. And we can't see the test, but yeah, there we go. Okay, so that's still running. Cool, that's what we want. But as it turns out, we can do this more efficiently. I mean, we're talking about a word character here. So we have a built-in for that, \w. Those are word characters. So let's run that. And there we go. We've got word characters. Now, one difference between what we had there just a second ago and what we have here now is I believe a word character is also going to include letters. So we could do return, of course it includes letters. What I meant is numbers. So like for example, is this considered a letter? Yeah, that's considered a letter. So that's a bit different than we have over here. But I guess what that's telling us is the 6 tests we have here are not covering any scenarios where there's a number involved, or at least, not in the longest word. So we can get away with this, but keep in mind, if there were more tests here, if there was more test coverage, then yeah, we probably would want to maybe clean this up a bit and maybe just go with what we had before with like that A to Z kind of thing. But anyway, this is working for us. We can use our regular expression here. But here's the thing. If we're going to use regular expressions, then maybe we can do this whole thing a little bit differently. So check it out. In fact, let's do all of this differently. Let's even get rid of that. If we're going to use regular expressions, we might as well do something like this. We want to find all of our words first of all. Let's say let words be assigned the value of, and we'll take our regular expression, our word character, and we'll do a dot match on our text. Or wait, that's got to be the reverse. So we've got to do it like this: text dot match. And then we've got our word thing there. So let's run that, and that's not returning anything, so we'll get a null. Now let's return words on that. And there we go. We're just getting the R because I forgot about the global flag. So now it's going to look for all of these things. And now we're finding it. Yeah, it's finding every single word character, but it's just separating them all as different things, like unique entries. So instead we'll say, okay, we'll put a plus on there to say not just one word character, not just one letter, but one or more letters, one or more consecutive letters. So let's try running that. We're looking for one or more consecutive letters. Hey, look at that. Ready, steady, go. We're getting all 3 of those. We're getting all 3 of those. We're getting all 1 of those. Okay, great. So this is matching what we wanted to match. It's giving us this array of words, which really, took a lot of work to get the first time around. So, okay. We're getting words now. The thing is, we still need to find the maximum one of those. Now down here, that basically we're at this point. This is basically, if we were to just take this, in fact, or copy this, paste it in there, run this, it really shouldn't be any different. Oh yeah, we're returning words. There we go. So here, get the words. Find the longest word. That's basically what we're doing. So is that going to work? Is that going to pass all the tests? Yeah, it is. Okay, cool. But can we do it better than that? I think, yeah, we can. Okay, so basically we'll get the words by doing this, and then finding the longest word. Here's what I want to do. First of all, we could do something like this. Let's say words.sort. Okay. Let's just run a words.sort, and for now, let's just return words, okay? So we'll see what that sort is doing here. Well, basically right now it's sorting them like they're, like it's a dictionary or something like that. So it's just doing a lexicographic sort. That's not exactly what we want. So we're gonna give this its own sorting function. Now, when we're dealing with numbers, if we want them to go up, like in ascending value, we would just do something like this, A minus B. But in this case, we're not comparing these like numbers because they're not numbers. What we really want to be comparing is the lengths of these things. Okay, so A.length minus B.length, and now we find it's sorting them in order of their length here. So if we want to get the last one, which is going to be the longest one, we could do words at words.length minus 1, and that should give us what we want. That should give us the longest one here, and it does. Or we could also, if we just want to get the last one off there and we don't need to use this array for anything else, we just pop it off the end and it's going to be the last one. There we go. Okay, well that's nice. Or we could flip these around. We could say, well, let's look at the reverse of that. So instead of getting them going in ascending order of length, let's get them in descending order of length, because that way we can just say words at 0. It's even fewer characters than words at pop, so that's nice and efficient. Okay, so this is pretty not bad. We can use sort to get the words, find the longest one. But could it be better than this? I don't know. We've really improved this a lot. If we take a look at like our first algorithm versus our most recent one, we've definitely economized. Like the first one was well, longer than I can fit on the screen at once. This one, yeah, pretty efficient. Well, I guess it's the same as this. Pretty efficient. It's not taking up a lot of room. But could it get better than this? Well, yeah, I think so. So we're going to use the same sort of principle as this, except we're going to take advantage of reduce. Okay, so we're going to do a words dot reduce. Okay, so keep in mind the way reduce works is it's basically taking an array of stuff and reducing it down to just a single thing. So we might want to do something here like, if we did A plus B, right? Or A concatenated with B. This would just put all the words together. Or, maybe we want to put them together, except we want to put something in between. And, for example. So now when we reduce all this, ready, and, steady, and, go. Okay, but instead, what we want to do is, instead of just putting these together, what we actually want to do is just say, okay, well, we want to reduce this, and basically what we want to do is we want to say, if a dot length is greater than b dot length, then choose A. Otherwise, choose B. And this way, it's just going to sort of keep the maximum length one as it goes through here, and it's going to do this reduce, and there we go. So it's just giving us the one that's going to have the longest length. So basically the way this is running is, actually, you know what? Here, let's make some space here. That is such a hard thing to pinpoint. There we go. All right, so then we'll make lots of space. Okay, good, and we'll even do that. Okay, so we've got lots of room here. Let's get a nice color. Let's go with, like a light orange. Whoa, hey. Yeah, okay, there we go. So now, what was our array? Actually, let's not go with the existing array. Let's make a new one. Okay, so it'll be hey. Hi. And what? And maybe, what have we not covered? Okay, A. There we go. Just so we have some variety over here. Okay, cool. So now let's talk about how we're going to go through this one, how the reduce is going to work here. So basically, for the reduce, we're going to have a value for A over here and B over here. I guess I shouldn't have called that one in. Oh well. It's too late now. So we're going to put A over here. We're going to put B over here. And basically the idea is that when we first start our reduce, so A is just going to be this first one. So A is going to start out as hey. And B is going to start out as this one, hi. And then basically the idea from here is we'll run the reduce. We'll say, well, is the length of A greater than the length of B? And if so, we're going to store A. Otherwise, we're going to store B. Now keep in mind for a reduce, when I say we're going to store A or store B, what I'm talking about is as the value of A. That's how reduce works. So whatever the result is of this thing, okay, so basically we start with the first two things. Whatever the result of this is, that's going to get stored as our value for A. Whenever, the next thing, so what in this case, is going to be the value of B. So B is going to be going through this. B will be high. Then it'll be what? Then it'll be whereas A is just going to store whatever we're returning in each of these cases. So basically, which of these has the greater length? Does A have a greater length than B? Well, yeah, it does. So we're going to return A in that case. So A is still going to be hey. And then B is going to move on to what? Because it's just the next thing in the array. Okay, so then from there, we're going to compare them. We'll say this is A and this is B now. And does this have a greater length than this? No, it doesn't. So we're going to go with the second one. So now A is going to be what? Okay, great. And then B is just going to be the final string here. And we'll say, does this have a greater length than this? Yeah, it does. So we're going to go with this, and we're going to stop there because there's nothing else. So B is not going to take on another value. It'll just return what it has in memory already. It's this one. And notice that was the longest string in this array. So that's what we're looking for. Okay, cool. So that's it for that. Thing is, And I guess we can clean this up a little bit now. The thing about this, ooh, there we go. Okay. We're finding words. We're doing a reduce here. Now, down here, we sort of needed to keep words over here so that we could then do a sort, which is a mutating function. So it's actually going to change words. Like we're not saying, words assign the value of words.sort. We're just saying words.sort, and that's actually going to change it. So we needed to like declare it, assign it, then modify it, and then return the thing that we're looking for. Over here, well, we don't really need to do that because we're saying words is going to be this, and then we're going to return words.reduce on that. So since words is just this thing right here, we can just replace this with that thing. And is that going to work? Yeah, it's going to work. Okay, so I think this is fairly obvious. I'm actually going to delete that comment now. And there we go. So let's see if that passes the hiddens. It does. Okay, so that's pretty neat. I mean, we started with something that was like very long. We cleaned it up a little bit, and then we sort of rethought how we were going to look at it. We brought in regular expressions, and as they tend to do, it made it a lot more compact. I mean, this is like one line right there. Okay, cool. So that's good. That's working. If you have any questions, comments, concerns, definitely feel free to let me know. As for now, I guess we'll finish up with this one. So nice job. Let's get out of here.